All right, guys, welcome back. Yet again, this is part 3 of genetic recombination and gene mapping. We're finally, in this part of the video, we're going to get into how you actually calculate the relative distance and construct a basic chromosome map. So the first video, I went over the underlying principles and kind of how this works. Second video, I went over how you can determine gene order based on by comparing parental genotypes to the double crossover genotypes and seeing what changed. In this video, we're going to talk about actually calculating these values of centimorgans, which we'll get into in a minute. All right, so this is just reiterating the question. Drosophila fruit fly, consider the linked alleles yellow body, cut wings, and echinus eyes. And then we're going to go ahead and look at the data again. And this time we're going to kind of get into we're going to crunch some numbers and talk about how you can figure out basically the probability that crossover will happen between each of these alleles. So what is the likelihood of crossover between Y and CT? Remember in the previous video, hopefully you watched, that we determined that EC for echinus eyes is in the middle by comparing parental genotypes to double crossover genotypes. So I basically, just for visuals, I constructed like a theoretical parental chromosome. So this is parental chromosome 1, this is parental chromosome 2 right here. And they're noted in the table. It'll almost always be like this in practice problems. The table gives you the alleles in a different order than they actually are because they just want to make it difficult. So this is, echinus would actually be in the middle here, which we found out from the last time. So we know this is just the data, and we figured out that echinus isn't in the middle. So I went ahead and rearranged it here just for visuals so that you can think about this a little bit easier. So what's the likelihood of crossover between Y and CT? So you got to think about it. How can this happen, basically? If crossover can happen between Y and CT, it can happen here, it can happen here. So if crossover were to happen here, that would result in Y plus plus, which we have right here, result in plus echinus CT, which is right here, plus CT echinus. Remember, I switched the order just to make it match the table over here. So we have this one, and then it could also happen right here. So we could have yellow body, echinus eyes, wild type, or wild type, cut wings. So right here we have wild type, cut wings, and yellow body, echinus eyes, wild type. That's right here. So those are the 4 resultant results that crossover happened. So if crossover can happen, or for crossover to happen between Y and CT, it can either happen here or it can happen here. So you just go ahead and follow that and figure out what the 4 offspring genotypes could be and list those, and then you're just going to go ahead and match those to the table. So right here we have the first 2 possibilities, which are right here and right here. That matches up to cut and yellow body echinus offsprings, and there's going to be 293 and 282 respectively. So you're going to go ahead and you're just going to list those here, and we're going to add them all up. The other 2 are, let's see, wild type, yellow. So that's yellow right here, and cut wings, which is, oh wait, we already listed that one. And actually right here, echinus cut. So then we're going to go ahead and add up these as well. So we're adding up these 4 numbers, which are the 4 possibilities of crossover happening between Y and CT. Those locus is on the chromosome. Add them all up, we get 719, and then divide by the total number of offspring, which gives us a value of 0.25. So there's basically a 25% chance that crossover will happen between Y and CT. Next, we're going to go ahead and look at a different combination of alleles. So what's the likelihood of crossover between EC and CT? So now we're comparing not only the ones on the end, now we're comparing the middle one to this one, and then we're going to compare this one to this one. So EC and CT, what are the possibilities if crossover happens between EC and CT? Well, in order for that to happen, it really can only happen this way. So it can create yellow echinus wild type, which we have yellow echinus wild type right here. It could create wild type, or cut wings wild type, which is right here. And then I guess the other way it could happen too, this is where it results a little bit in creative thinking, but What about if double crossover happens? So that's the one way it could happen, is if it was right here. But what if it happens here and here? Probably not very likely, but that's another way that crossover could happen between EC and CT. So we're going to go ahead and look at what would happen there. It would create yellow body, wild type, cut wings. Yellow body, wild type, cut wings. That's one option. And then the other one, we have wild type, ecnicize, wild type, which is right here. So we have to not forget about that double crossover possibility. So we're going to go ahead and, again, just match them up. So we got here and here to there, and then here and here to, again, up here. So these are the four possibilities that could happen if crossover were to happen anyway between EC and CT. It's going to be 293 plus 282 plus 6 plus 4 equals 585. Divide that by the total number of offspring, and that gives you 0.203. So there's basically a 20% chance that crossover happens between EC and CT. So let's go ahead and, just for the fun of it, let's go ahead and compare that. So this is bigger than that. So there's a higher likelihood that crossover will happen between Y and CT than between EC and CT. What does that mean? Critical thinking. It means that this is probably closer together. These two alleles are probably closer together than Y and CT, because there's less likelihood that crossover happens between them. Okay, I don't want to take too long, but now we're going to look at that third allele. So we've already looked at Y and CT, and then we've looked at EC and CT, and now we're going to look at Y and EC. So the ways crossover can happen between Y and EC are either right here, or, again, a double crossover happens there and there. So here, it would be Y, and then drop down, wild type, wild type. So we have Y, wild type, wild type. It'd be wild type ECCT, which would be right here. Yep, right here. Or it could be the double crossover, which would be Y, wild type CT. Oh, sorry. Or wild type EC wild type. So then again, go ahead and match these up right here. So I think you get the point at this point. Then we're going to go ahead and add up all those numbers and divide by the total number of offspring, which gives us a value of 0.053. Now note that that is extremely small compared to both of these other probabilities. So there's a very, very low probability that crossover happens between Y and EC. What does that mean? Probably that they're very close together. And that would make sense because there's also this number, although it's smaller than this probability, it's not that much smaller compared to like 0.053. So we can kind of surmise here, just thinking about it, that Y and EC are really close together on one end of the chromosome. So there's a very low percent chance that crossover happens between them. And then CT is probably way at the other end, because Y, the difference between crossover happening between Y and CT and EC and CT was not that much different. So then we're going to go ahead and look at our map, which we built, and yeah, that's what we see here. So there was a 20% chance, roughly, that crossover happens between EC and CT, and roughly, remember, a 25, I think it was 0.25 chance that it happens between Y and CT, and then only a 5.3% chance that it happens between there. So these are called, these units are centimorgans. Again, it's a relative unit. It's not telling you that this is however many micrometers away from this other gene, but it tells you that it's based on probability and frequency of recombination frequency. But notice this. So in theory, the distance between Y and CT would be, you could just add these up. We have 5.3 here and 20.3 here, and you add them up and it equals 25.6. But when we calculated it, if you go back, we found the true distance to be 25, or 0.25. So what accounts for that discrepancy? Well, if you know, looking back at our original calculation, we didn't add in the double crossover. That's the issue. So we could have had, when we said Y and CT, we said crossover can happen here and crossover can happen here, but we didn't calculate the probability that crossover happens here and here. So now we're going to go ahead and add that in. And by adding double crossover in, like so, go ahead and add 6 and 4 in there times 2, because there's 2 ways double crossover can happen. You're going to get 25.6, which is exactly equal to what you get if you add up these two distances. So now we have a relative, right here is the centimorgans. Now we have our relative chromosome map, and we can figure out, it's pretty straightforward if you think about it. It sounds complicated and pretty intimidating at first. I was very nervous about it when I first tried it. But then, just taking practice, it really is kind of not as difficult as it seems to figure out where these genes are on a chromosome. It's kind of cool. Okay, so this is just a summary slide to kind of help you remember. This is how I think about it. Step one, you look at the problem and you look at the data and identify the parental genotypes. And you do that by, it's going to be the most common genotype in the offspring. So next, you're going to go ahead and find the double crossover products, which is going to be the least common. And then by comparing those, you can figure out which locus is the middle, and then you calculate the probability of crossover between each locus using the genotype data, and then you create your chromosome map. All right, guys, that's it. Congrats on successfully mapping a chromosome. I hope that this makes sense and wasn't too confusing for you. If you have any questions, feel free to reach out to me or someone at the ASC, the Academic Success Center. Here's the information, and hopefully you're able to follow along and feel confident that you can go ahead and solve these problems on your own. Thank you, guys.